buy batteries in the middle of the jungle. So don't worry about the batteries part. It's not the ideal thing. Yes, we should run them on solar cells and so on and so forth.
But you can always adapt it.
Yeah. This will go anywhere. You show this to anybody in a third world country and they would know what to do with it immediately. Okay, so they're running a little fan in there. It doesn't draw a lot of power. I put these batteries in. I got these like 3 years ago, and I think I finally replaced 2 batteries in one of these earlier this year. Like? Oh yeah. Okay. Here, let me put the.
Yeah. Go ahead.
Okay. All right. Now, so what happens is that this can sits inside this can here, like this. All right. So the air is being blown up from the bottom through this double wall chamber. All right. What happens whenever you have moving air past the hole?
I mean, it blows up, does it not? It would blow up through the chamber itself.
As you have airflow past the hole, you create what's called a Venturi effect. There's a low pressure zone. Ever take a Coke bottle or pop bottle and blow over it? Well, that moving air across the top of the bottle is creating vibrations inside that plastic or glass container. Okay? So actually what happens is that as the air is coming back here, the fire that's in here, the smoke goes out these little holes, mixes with the fresh air coming up here, comes out these little holes, and burns in a magnificent little swirl pattern. All right, just concentrating the heat energy and burning it very cleanly. Right now, all I've got in there is ashes, but so this is called a stratified downdraft. It's a modified stratified downdraft gas plant. But so there are various forms of gasification. There's updraft, there's side draft, there's downdraft, there's fluid bed, there's molten salt reactors, blah blah blah, plasma reactors, all kinds of things. You know, I'm not saying that this is the only thing, but by manipulating materials in different ways, we can form them, put them together in such a way to accomplish a specific class of tasks.
Would you mind, I didn't have this on video earlier when you were talking about giving sort of the introduction of the, if you go into a third world country?
Yeah, these were made, actually they started research back in the 80s because they recognized that third world countries were consuming a lot of forest resources, and so they actually did it first for health resources, and then they found out how efficient these were in converting wood into heat energy and doing it cleanly and with a lot less smoke, and so the women were getting a lot less carbon particulates in the lung and so on and so forth from breathing the smoke. And this uses 1/3 of the fuel, wood fuel, that one of their traditional open fires cooking fires would normally use. So it was reducing wood consumption by 2/3.
So would they put a pot on top of this?
Yeah. This is it. This is a little thing, and then you just kind of put a pot on top of that, and you know, put your water and your whatever food in there and cook it. And I got a big pot at home, stainless steel, and I put a steaming basket in it, and I can steam 4 or 5 large potatoes on 1 load of fuel in there.
Could you show how the whole contraption goes together? Maybe demonstrate setting it up?
Well, basically, I mean, these come together. I took this one apart so people could see how it works. So basically,
so that's just a larger one of these.
Pardon me?
The silver one is just a larger version of the green.
Pick up food for the,
yeah.
I'm sorry for.
It's an absolute pleasure.
Well, yeah, come on. If you have a question, come on by. I'm going to be here all night.
So, yeah, us too, actually.
Okay.
Thank you so much.
And what is your name? James Womack, huh?
James Womack. I'm from Sylva.
Well,
so I've been doing this for about 3 years, demonstrating it. I've been studying biomass gasification for about 10 years, and I finally said I got to try it. So this is a relatively inexpensive setup. proof of concept kind of setup. It's not meant to be a long-term power output, but it runs long enough so that people can see it and understand how it works.
So there's smoke coming out of that large barrel there.
The fire has been shut down, but heat expands, and so I have to let it out somewhere.
So what does this thing do? It's being
starved of oxygen, and in about 2 hours after a shutdown, it'll be cold.
So
then I have to go through a complete startup process again.
That contraption will run the generator?
Yeah, that is basically a solid fuel to gaseous fuel refinery.
And where does the electrical outlet?
The electrical generator is here on this end. And basically what you do is you put in wood there. You've got an extremely hot fire down here in this section. Okay. In fact, it's so hot you can't put your hand on it.
Where's it getting its air from?
It's getting its air from here, but there's a cap on it right now to smother it so that I don't burn up all my fuel. But I can restart this at any time, and then as I'm to get a good quality gas, I got to get this back up to temperature, so I'll start this up and this will flare and make a gas flare. And then once I have a good quality gas being produced out of here, then I will shut this down, open this valve, and then the gas will run into the engine and run the engine.
Very interesting.
So wood is a hydrocarbon. It's a complex sugar. Hemicellulose, cellulose, and lignin are all complex sugars. Sugars are hydrocarbon. No different than gasoline in your car, except the gasoline is the molecules in gasoline are linked together in a way such that they make a liquid, and a high density liquid, and very convenient, and that's why everybody likes it. But wood is a fuel also, and it's a hydrocarbon, and actually 20 pounds of dry wood has the same energy content as 1 gallon of gasoline. So it really doesn't take that. 20 pounds is about, each one of these buckets here can hold about 13 pounds of wood. So 2 of these buckets will run that generator for an hour, or 1 gallon of gasoline will run that generator for an hour. The difference is that this wood is carbon neutral, the gasoline is fossil fuel. All we're doing is recycling carbon here, whereas if you use gasoline, you are adding that much more carbon to the load.
So what happens to the to what is not the gas, the remainder?
The wood burns so completely that it's ash and just a little bit of char left. So it's about a 95% conversion rate, and what's left over you can put in your garden, and I do. Huh. And it's not biochar, it is actually charcoal, and it's not as good as biochar, but it is beneficial. So with refining crude oil, you have tremendous quantities of waste materials. With this, everything is recyclable.
Wonderful. Thank you for setting this up here.
Yep.
Do you mind if I put it on YouTube?
Well, there are hundreds of these on YouTube already.
Well, I'm going to be videotaping various things around.
Oh yeah, you can put whatever you want. I mean,
okay,
I'm just trying to say is that this is nothing new. This technology here is 150 years old.
Yeah.
So I'm just pointing out that everybody, I mean, somebody who hasn't seen this. The reason I'm doing this here is because 350.org is promoting climate awareness. And I clearly understand, I have enough of a science background to clearly understand that we are in deep trouble right now with our climate situation. And I used to actually live right down the road from Jim Hansen, who used to be NASA's chief climatologist up in Greenbelt, Maryland. And so I became familiar with his work back in the 80s, the middle to the later 80s. Anyway, so over the years, you know, I began hearing about this, and I wondered in my research, and I just decided to try it out, because you can only study something for so long, and then you got to try it.
And do you use it, actually use it yourself?
Oh yeah, I've used it.
Yeah.
I mean, this isn't a long-term. I'm getting another system that's computer controlled and computer operated to run 40 or 50 hours straight, and it's far more complex than this, far more costly, but on a cost-benefit ratio, it'll do. This is just a demonstration unit. This is as simple as you can get and still get it to work. And the only reason even if I had that more sophisticated unit, I would bring this along with it to show people that you don't need a computer to run these things. You don't need, sophisticated technology. But that sophisticated technology makes it
easier.
Yeah, makes it easier.
Will you be able to heat your house with
Oh,
this?
sure. In fact, what you would do with this, the ideal setup is you run your generator, and the waste heat would be used to heat your house. So you make all your power, and whatever extra power you're making that you don't use, you can put back on the grid. And the waste heat, because some of the heat we have to run a thermal chemical fuel refinery. You have to use heat to break down the hemicellulose, the cellulose, and the lignin into a usable fuel. And so, but once we do that, the waste heat can then be used to heat a house or a greenhouse. And that combined process is called combined heat and power, where you're producing power and heat with the same unit of fuel. There's no sense in taking one unit of wood and making electricity with it, and taking another unit of wood and putting it into a stove and heating your house with it. All right?
Yeah. How much wood would it take to heat your house and provide lighting with this new sophisticated system? How much wood will it take?
Well, this system right here will put out about 4 kilowatts. That'll run about 2 average size homes.
And how much wood does it take per day?
This'll on a 24-hour day. Okay. About 500 pounds of wood.
How does that translate into cords? Do you know?
Oh, well, a cord is about a cord of hardwood. Generally, by most people's calculation, is about 3,000 pounds of wood. So that would be
6 days of heat for 2 houses.
Yeah.
Huh. Very interesting. Thank you very much.
Or 12 days for one house.
Yeah.
But it is heat and power, and you're going to make a lot more power than you can possibly use. So you could put some of this power back on the grid and get not only paid for it, but also collect renewable energy credit to help the state of North Carolina achieve their 12.5% of power by 2021 supposed to be from renewable energy. That was a 2007 law that was enacted.
So this is thinking globally and acting locally and being responsible.
And we can do this. This is not to replace solar. This is to be used along with solar, along with wind, along with microhydro, with our other renewable energy resources. This has some distinct advantages and some distinct disadvantages. But I call biomass gasification, I call it the neglected child of the renewable energy family. Because not many people know about it. Boy, they know about fireplaces, they know about wood stoves, but they don't really realize what's actually going on there, and that the wood that they're burning is actually a hydrocarbon fuel, just like gasoline or diesel fuel.
It's being wasted.
Well, it's not being used to its maximum advantage. That's my only point. And so if we're going to solve this climate crisis thing and use our resources wisely, we have to use our fuel and our solar and wind and technologies and everything to their maximum advantage. And this has a special role to play. It's not the thing. It's just part of the renewable energy mix that's required to help us achieve a sustainable world.